Bismillahirrahmanirrahim. Assalamu alaikum. We are here to discuss our final year project and its title is Designing of Thermal Imaging Camera for Moisture Detection. And our group members are Hijab Amit, Faizan Javed and Qasim Abbas. Our respected supervisor is Dr. Tassadaq. My name is Hijab Amit and I am going to tell you about what is a thermal camera, about its working and major application. Firstly, we start with what is the thermal camera. A thermal imaging camera is all about displaying objects of different colors and colors that reflect different heat dimensions. It is known as a heat camera too. According to color gradient, color red to white indicates high temperature and color purple, blue, light blue to green indicates a low temperature from the environment and usually on a wet or wet area. Thermal camera operates on a high-tech principle called thermography, a field of science and physics in particular. This field is established on the absorption of infrared radiation emitted from any object whose temperature is above 0 degree. It absorbs and processes electromagnetic radiation within the range of infrared wavelengths of 1 to 14 micronanoseconds. Here you can also look at figures of the electromagnetic spectrum and color mapping of temperature. Further, we talk about the application of the thermal camera. It has various applications in every field, but we mention some of them, which are electrical, industrial, mechanical, agriculture, and many more. Now we talk about how we can detect moisture by using thermal imaging. Basically, in general, moisture detectors are that sensor which measure the water content in soil or crop. There are different type of moisture analyzer and maximum sensor directly get in contact with soil to measure moisture content. But contactless or pinless are easier to deal with, most effective to measure moisture, and it operates by emitting electromagnetic waves, either radio wave or an electric current. The measure of moisture content during thermographic meta-analysis defined moisture as the loss of mass of a substance when heated by the process of water evaporation. The substance difference is continuously calculated and recorded by a precise balance. In this way, we get result of detection. In the end, we can say that it helps in managing aggregation system more effectively and efficiently. Let's talk about what is the importance of the moisture detector. As we all know that agriculture is the most important sector of Pakistan economy and there are many issues caused by moisture in crops. So the solution for industrial need is a cost-effective, automatic, contactless moisture detection system. It deals with crop moisture, heat, temperature and humidity. Now problem statement is automatic, precise, contactless and intelligent system is required as already available moisture detector have low accuracy, dedicated hardware in contact, no flexibility, are manually operated and yet more costly.
Bismillahirrahmanirrahim. My name is Qasim Abbas. Now in this slide, I am telling you about the proposed aims and objectives of our project. Basically, we are proposing development of a high precision contactless system for an agriculture application that detects the moisture and temperature of crops using thermal imaging sensors. It then processes it and using a microscopic based system used and take advanced decisions. In this slide, we have studied some available moisture detectors that are already present in market. We studied these moisture detectors, collect the data and shown in the tabular form. We have studied 5 research papers about available moisture detector having a different moisture sensor and different processing unit. First, in this table, first we have author name, then the title of research paper, next one is the published year, then moisture sensor used in the paper, and last one is the processing system that process the data through moisture sensor. In this slide, we have a comparison table between 7 different thermal cameras. These comparison table shows complete market view, and we have research on these cameras and put the data in tabular form. In this table, we have shown the different things about thermal camera, like its model, brand, range of temperature, field of view, distance, flashlight, its battery, photo and video portable, sport thermography, or its price, and it's waterproof or not, and other most things that are shown in this table. And there are a different thermal camera, like thermal app 1000, Seek Thermal Compact Pro, thermal app TH110, Fortrix 228 Blow, Flare 1 Generation 3rd, Seek Compact XR Outdoor, and Perfect Prime IR 0102. And these are the cameras and that have their own specs, and each camera is better than the other one. In this section, I am going to explain the methodology of our project. The methodology contains three main parts. First, sensor unit, other one is processing unit, and the last one is programming environment. Let's come to our sensor unit. In sensor unit, basically we use two main sensor. The first one is thermal sensor and the other one is display sensor. In thermal sensor, we use MLX9640 thermal sensor for our project. This sensor have resolution of 32x24 pixels and have operating temperature of -40 degree to 85 degree centigrade, and similarly the targeted temperature is 40 degree centigrade to 300 degree centigrade. This sensor is I2C compatible and have digital interface with processing unit, and have a programming refresh rate of 0.5 Hz to 64 Hz. The supply voltage of this sensor is 3.3 volt, and it consumes less than 23 milliampere current. And in this we have two field of views. One is -55 degree cross 35 degree, and 110 to 75 degree. Let's come to a display sensor. In display sensor, we have used 7-inch LCD, have maximum resolution of 1020 x 2048, and it's also provide a HDMI port for interfacing. Now the second part is processing unit. In processing unit, basically we use Android XU4 single board computer. This processing unit including 8 processing cores, DRM, SDRM memory of 32 GB, I2C interface for camera unit, and HDMI interface for display unit. This Android XU4 have 8 CPUs, in which in that contains, and it's based on RAM architecture and has 4 parts, which have high performance Cortex A15 quad core processing block, low power Cortex A7 and quad core block, and GPU and as CPU. In this board contain real-time current sensor that measure the power consumption in 4 separate domains, like A7, A15, GPU, and DRM. The processing unit of this the processing unit, it contain all components like camera unit, which an I2C interface, and display unit with the HDMI interface as a system for data acquisition and shown the result. Now in third part, programming environment. In programming environment, we use we use Python language and OpenCV to program the thermal imaging application. Now come towards the execution of the camera. We have a source code of camera that we run on Python 3. After this, the camera will be on, and this camera measures the temperature up to 38 degrees centigrade. If the temperature increases to 38 degrees centigrade, the beep will start, and on screen we show different colors that indicate the different heat patterns. Now in the source code, first we have include the libraries in the code, and Then we have serial interfacing and reset the ports of hardware. And then we initialize two temperature, one is maximum and one is minimum temperature. Then we read the data from ports serially, and at the end we have a color map. In next slide we have design proposed block diagram, in which we contain three main blocks. The first block contains sensor, in which we have different sensors like thermal, infrared and CMOS sensor. And these sensors collect the data and send to our processing system. The next block is processing system, and processing system process these images images or data that's come from the sensor, and after process it, then sent to our the next block, in which the data that's come from processing system um, works on the principle of image processing and machine learning.
Assalamu alaikum. My name is Faizan Javed. Now I will tell you about the last part, results and conclusion. First I will tell you about the results. In the very first slide, in this results slide, we have an image from our demonstration video or the prototype video. The image shows a thermal image which has a thermal pattern, thermal signature. The blue color shows the hotness, shows the coldness, which is the minimum temperature, and the red color shows the hotness, which is the maximum temperature. In our camera, we operated by using Python language. We open our source code, we give the command and press enter, then our camera is on. We have a setting for our thermal imaging camera. We have set 38-degree threshold temperature. We have given a threshold temperature of 38 degrees. When it detects a temperature above 38 degrees, it beeps. जावेद है और हमारे सुपरवाइजर हैं डॉक्टर तसद्दुक साहब, और हमारा ये टाइटल है डेवलपमेंट ऑफ थर्मल इमेजिंग कैमरा फॉर मॉइस्चर डिटेक्शन। और इसमें हमने बनाना ये था कि जो पहले अभी तक थर्मल इमेजिंग कैमराज हैं वो कंटैक्टलेस नहीं है, और जो हमने अभी जो कैमरा बनाया ये कंटैक्टलेस है और प्रिसाइज टेम्परेचर मेजरिंग के साथ ये थर्मल इमेजिंग कैमरा है हमारा। इसमें ये जो हमारा थर्मल इमेजिंग कैमरा है, अब इसके हार्डवेयर पे आ जाते हैं। ये हमारे पास इसमें थर्मल सेंसर लगा हुआ है जिसकी रेजोल्यूशन है हमारे पास 32x24, जो कि इसके पिक्सल्स भी हैं। उसके बाद ये हमने इसको कनेक्ट किया हुआ थर्मल सेंसर्स को इस सीरियल केबल के साथ, जो कि जैसे रॉ इंफॉर्मेशन और डिटेल जो जा रही है वो सीरियली हमने कनेक्ट की हुई है यूएसबी पोर्ट में, तो लैपटॉप में जा रही है। और उसके बाद ये हमारा कोड है पाइथन का, और ये इसका सोर्स कोड। हम आ जाते हैं इसकी एग्जीक्यूशन पे। ये हमारे पास सोर्स कोड है अपने थर्मल कैमरे का, और इसको हम पाइथन 3 पे चलाएंगे और ये कैमरा ऑन हो जाएगा। इसके बाद इसकी वर्किंग कुछ इस तरह से है कि इसकी सेटिंग इस तरह से है कि ये 38 डिग्री तक टेम्परेचर मुहैया करेगा, और उससे ऊपर अगर कोई भी टेम्परेचर आता है तो ये बीप करता है, जैसे कि ये अभी कर रहा है। और इसमें जो येलो कलर है वो सबसे लाइट टेम्परेचर को शो कर रहा है, ब्लू कलर जो है सबसे लाइट टेम्परेचर को शो कर रहा है, और रेड कलर जो है वो सबसे हॉट बड़े टेम्परेचर को शो कर रहा है। उसके बाद ये हमारे पास कैमरे का सोर्स कोड है। इसमें हमने सबसे पहले जो है लाइब्रेरीज इसमें इंक्लूड करवाई हैं फर्स्ट पार्ट में, और सेकंड पार्ट में हमारे पास आ जाती है सीरियल इंटरफेसिंग और जो हमने हार्डवेयर की पोर्ट्स रीसेट की है। उसके बाद यहाँ पे हमने दो टेम्परेचर मैक्सिमम और मिनिमम इनिशलाइज किए हुए हैं, और उसके बाद थर्ड पार्ट में हमारे पास आ जाता है सीरियली जो डाटा हमने रीड किया है पोर्ट से, और जो लास्ट पार्ट है उसमें हमने यहाँ पे जो डिफरेंट टेम्परेचर है उनको डिफरेंट कलर्स दे दिए, मैपिंग की हुई कलरिंग। In this slide there is an image from also from the prototype video, and in the image there is the source code, and we are executing the source code, and we on the thermal camera and check the temperature and humidity of any product. Now I will tell you about the performance of our thermal imaging camera. Our thermal imaging camera has the ability to convert near infrared signals to thermal images with an accuracy of plus minus 2 degrees Celsius. Our thermal imaging camera is a low resolution thermal camera having a resolution of 32 by 24 pixels. Our thermal imaging camera can process 10 frames per second with an angle of view of 90 degree. In this slide I will tell you the conclusion of our project. We developed a thermal imaging camera for agricultural purposes, having a very low resolution, low cost. It's very cost effective. Uh, it's a very high performance, very accurate, and it works in real time. Uh, our developed system uses a thermal imaging camera that takes raw images as an input and then convert these raw data or information into thermal images and then display them on the screen for temperature and humidity measurement.
Here we have mentioned some references of different research papers which we have studied. Thank you from our side. If any question, just ask.